Hello everyone, I'm Sao Liu. Uh, this work is done. I'm in an internship at Shanghai Air Lab, which is about think and act. In later this year, I will join the Beijing Academy of Artificial Intelligence. Okay. Uh, as we know, robot manipulation often suffer scale forgetting issues. We want to solve this part through the primitive prompt. Okay. Uh, First, in this work, we propose a primitive prompt learning method. First, I want to explain what is the primitive. Primitive is a subset of the whole demonstrations. We want to use some small actions or a multi action sequence to replace the single action to simplify the non-horizon task. And besides this, we master achieve the lifelong robot manipulation. So we import reusable and extensive primitive prompts. Okay, uh, in in this way, we present the motion-aware prompt via text and flow query, which is designed to represent a shorter primitive between the scales, and we can efficiently transfer the scales to the new task or new scales. Okay, finally, we construct a very large scale data sets, which is not similar with the previous data set. We divide the robot data set into the scale or primitive data sets to achieve a more efficient scale transfer. In we can see the primitive is the division of basic tasks. Uh, for example, for a manual cleanup task, we can divide into open journal, grasp mark, and pick marks as three subtasks. And for each subtask, we can continuously divide into some primitives like left and turn right. Okay. Uh, the minimal action unit is the primitive we proposed. Okay, this is the whole overview of our PPL. First, we would inject RGB images and language instructions, which is the common setting. But we also inject a new model, is optimal flow. Why? The optimal flow can efficiently capture the moving informations. This is the most important we think to transfer the to transfer the knowledge, but not just from the language levels. Okay, and how to reuse our skills? We think optimal flows may show the most important transfer or common knowledges. So we in the first training stages, we pre-train much or I can say about 14 primitives in our large scale data sets, and then we can weighted these primitives and add some initialized promotes to achieve uh, and these things to get the final new scale primitive prompts. And then we inject these things into the common diffusion policy head or piling like flow matching method. This is okay. Okay. Okay, in this way is motion aware promoting. Uh, it's it's querying the language and the motion to get which part of the tasker process, and and the way is very easy and efficient. We can just use the MLP to inject all information in this part. In the left, we can see the optimal flow is focused on the robot itself, but not and the moving objects. Okay, this is impact of our MAP on the problem weights. For just text only, we found different scale, different task cannot efficiently distinguish the task one okay, the tasker grasp and the tasker place. But our text and optimal flows, we can easily distinguish which part do you which part the robot are going. Okay, for the texture and the flow information fusion, we use a very simple and efficient way to sum promotes to get the efficient to gain a greater performance. We can see the alpha M is the cosine similarity of attention query and the prevails prompt K. It can evaluate or measure the similarity of our current task and the previous task primitives. Uh, okay, uh, this two part is our design for implement. We have to see our scale data set is the most largest scale level data set. It including the simulation and real world data. The simulation is constructed upon the labral, mimicking, and some area bench data, I think. For the for real world, we connect about eight tasks and about 4,000 actions for each task. Therefore, these two both constrain our scale data set and and through two-stage training to extract corresponding primitives and the new tasker primitives. Uh, I okay, I cut some important result, but I think the most interesting result is this one. The ablation study, we found our method can filter different or various lighting conditions. We can say about warm light, half warm and half cold light, and dark light for setting. Our method achieve great performance compared with the method with text-only prompts. But we also can see the text only or flow and text method is harder to or hard to distinguish in the cold light conditionals. Therefore, we will explore our method in the future work to generalize to more general lighting conditionals. But I think this work can give us some insights. Okay, the right one is the detailed ablation studies about the primitive numbers and the primitive baseline and its and its performance comparison between the LoRa and the mixture of experts. Okay, that's all. For more details, welcome to our booth. Have a nice talk. We are in Beijing Academic of AI Artificial BAI. Okay, do you have any questions? Please.
Yes, hello. I have a question. How does the diversity of the skill dataset influence the generation capabilities of PPL across unseen manipulation tasks?
I see, I see. Uh, it's see manipulation. This page. Is this page or okay?
It was like this question, the diversity of the skill dataset.
Oh, I see, I see. Is that our data set between compared with previous data set, we divide the whole demonstrations into some sub demonstrations. This can more general because pick a place or pick and place may be contained by four small action like turn left or turn right or turn over some actions. But this but pick just this language cannot including this action informations. But this action may be more maybe constrained more common uh, action knowledges.